this week we are looking at, yes, the science of the Bermuda Triangle and trying to understand what happened here, what is going on, what are some of the myths, and then what is actually the science that we can use to explain what's going on. Okay, so I'm gonna go ahead and get started. So let's go. So first off, what is the Bermuda Triangle? I'm going to define it, and we're going to talk a little bit about what happened there, because maybe some of you are familiar, but some of you might not be. So here's the deal, guys. The Bermuda Triangle, it's an area of water that's shaped like a triangle, and it has points in Florida, Puerto Rico, and Bermuda. Okay, 3 points. And the area itself is about 270,000 miles, 270,000 miles of water. So as you can imagine, that's a lot of water that you have there. Okay, so 270,000 miles of water. And really, the term Bermuda Triangle was first created by this guy named Vincent Gaddis, okay? And Vincent Gaddis wrote for this magazine called Argosy. You guys see this magazine over here? And he said, okay, well, there's been a lot of deaths in this area. So I have a feeling there's some kind of conspiracy. There's something magical, mythical going on here that's causing all these disappearances and deaths. So he called it the Bermuda Triangle. And this magazine cover is what people saw and what really coined that term and why we think of it as such a mysterious place. Yeah, Owen, do you have a question? You have a question? No? Okay. So guys, the term was first created by this writer, and really the reason why the Bermuda Triangle is so well known is because many ships and aircraft have disappeared when traveling through this area. There's been about 924 deaths in this region. So in this triangle, a lot of strange things have happened, and let's see if we can figure out what's going on here, okay? So how did the Bermuda Triangle myth even start? Like, where did this come from, right? So it really started with reports from people who've been through the Bermuda Triangle, who noticed some strange things and just decided to kind of make them some kind of magical, scary, claim. So an example here is there was a Navy, US Navy was doing an airplane training, and they flew over the Bermuda Triangle. It was actually this crew of guys right here. They flew over the Bermuda Triangle, and this is their planes up here. Now, 5 planes and 14 men vanished. And the guy that was running the training, he was quoted as saying, "We are entering white water. Nothing seems right. We don't know where we are. The water is green, no white." So people were like, whoa, color changing water, pilots disappearing. Something's pretty fishy here. And also, too, guys, going back a little bit farther to Christopher Columbus. How many of you guys know Christopher Columbus? Do you know what did Christopher Columbus do?
He traveled across the Atlantic Ocean, and I think he passed the Bermuda Triangle.
Yeah, exactly. He passed through the Bermuda Triangle, and he said that he saw a bright light and a fire on the water. So when people hear these stories, they think the Bermuda Triangle, something fishy is going on here. Something magical, and there's been many other kind of mysterious disappearances and sightings, and it kind of leaves this fear of the area. As I'm sure that the reason you asked this question, whoever it was, I think was it Owen? But it's because
it was me.
It was you. Okay, right. It's kind of a big deal. It's a big myth, big legend, and nobody really knows what's going on. So what is actually going on in the Bermuda Triangle? So there's lots of legends, and a couple of them are that there's a mythical city of Atlantis that's underneath the Bermuda Triangle, and it's time portals. Some people think they're going on there. And yes,
I know one of them, but there's 2 actually. There's it's a portal to a new world, and aliens take over the ships.
Right. So there are definitely some theories. You're right on with what you said. There's some, kind of theories about what's going on, right? But guys, I think it makes a lot more sense when we look at it with our science glasses on. Okay, you can look at it with the spooky, myth glasses, that's fine. But when you put your science glasses on, it's going to make a lot more sense. And I'm going to present you, because this is a science class, I'm going to present you with the science behind the Bermuda Triangle. And you can choose to believe what you like, but I'll show you what is scientifically kind of been proven in a way, or somehow there's been scientific theories that might make a little bit more sense. So here's the deal, guys, with the science. So I have I put a frowny face. Some of these, myths are a bit questionable. But if we look at the science, okay, a couple things might be happening. One, there are a lot of ships that go through the Bermuda Triangle, a lot more than that go through any other part of the ocean. The reason why is because the Bermuda Triangle is very close to the equator. It's in a good location, so you have a lot of ships going through. So even though it might seem like there's a lot of ships sinking and airplanes disappearing in the Bermuda Triangle, it's actually pretty proportional to the rest of the ocean. Because there's so many ships going through here, you're bound to have more disappearances and deaths. Okay. Another thing, human error. What is human error? Can you guys explain that to me? Does anyone want to try explaining human error?
It's like a thing. It's sort of like it's one kind of human. There's many different kinds. Like human error can cause natural disasters, like mud volcanoes sometimes, and coastal flooding.
Right. So humans kind of make mistakes that can cause big things and big accidents to happen. So for human error, guys, the man that I quoted that was running that naval training, he was known for being really bad at navigation. So it's not very surprising that maybe he veered a little bit off course and got lost, and his ships disappeared, or I'm sorry, his planes disappeared, because he was known for being bad at navigation, like Homer Simpson.
Homer Simpson, yes.
Yeah. And then last thing, guys, is there also might be a little bit of a natural phenomenon. And I'll dive into those a little bit in the next slide, because that's where we start to get to some of the meat of the scientific theories of the Bermuda Triangle, and how ships and planes just seemingly vanish. Okay. Now, here's one thing I want to clear up, right? Most of the remains of the lost ships and planes that have disappeared in the Bermuda Triangle have been found, right? They didn't just completely vanish without a trace, for the most part. So it's important to consider that even though we kind of say, oh, something vanished, it was probably a crash that we found that the traces of the plane or the boat afterwards. But really, the Bermuda Triangle myth has spun out of control because people keep passing on stories, but they don't actually know what really happened, or if there were any human errors, or what the time of day was, or if the waves were high. There's a lot of variables that can influence people's trip through the Bermuda Triangle. Okay, so let's talk a little bit about, I said natural phenomenon. You're probably like, phenomenon? Like, what is that supposed to mean? Well, let's talk a little bit about what may be happening. This is one scientific theory. It's called the methane gas hydrate theory. We'll break it all down, guys. Don't be alarmed if you're like, methane gas hydrate. I've never heard of that before. So here's the deal. A hydrate. So basically, you guys know about the gas chemical elements. Can someone give me a gas chemical element that they know?
Well, one of them is nitrogen or helium.
Nitrogen, helium, neon. There's a couple of, yeah.
So there are elements include oxygen, hydrogen,
boron.
Boron is a solid.
Boron is not a gas. Good catch there. So yeah, there's quite a few gas elements, right? Now, here's the thing. Most gas elements can actually, I say most, there's a few that can't, but for the most part, they can turn into something we call hydrates, okay? And what is a hydrate? Well, hydrate is essentially like the gas is locked into a jail. It's like locked into a jail of water molecules. So imagine you have all these little gas molecules floating around, and they are like stuck inside of this inside this water molecule chamber, okay? So I put this little picture here. If you guys imagine, this is a great example of a hydrate, little hydrate. This blue area, that would be our water molecules, and inside would be our methane molecules. Methane's a gas, and it's trapping those methane molecules in.
Methane is made up of carbon and hydrogen.
Exactly. Yeah, right on. It's made up of those basic elements. So methane hydrate is basically methane gas molecules. They're surrounded by and trapped by frozen water molecules. So in order to make a hydrate, what do you think we need to make a hydrate? One of these hydrates I've been talking about. What do you think we're going to need? Give me the ingredients.
Flour, sugar.
Well, that would be good for a cookie, right? But for a hydrate, what we need gas molecules. We need water molecules. We also need it to be really cold, very, very cold, so that freezes those water molecules. And last thing you need, guys, is a lot of pressure. Pressure has to push down on the gas molecules and compact it into this like little ball of gas molecules and then frozen water. Okay. And the ocean is really a perfect place to do that. Okay. If you think about the ocean, there's lots of methane in the ocean. Methane comes from organisms that start to decompose at the bottom of the ocean floor. So when you get like when you get like mollusks or things like that live kind of in the ocean floor, they start to decompose. They end up releasing methane. So we have a lot of methane in the ocean floor. Now, also, what is in the ocean? What is the ocean made up of? Water. It's made up of water, right? The ocean is all water. So we have water. Now, do we have a lot of pressure? Yeah, we do.
Yes.
All the way at the bottom of the ocean floor, you have the weight of the whole entire ocean sitting on the bottom. So there's a lot of pressure.
Great amount of pressure.
Yeah. And it's also very cold, guys. If you think about the bottom of the ocean floor, it's very dark. You don't get much sunlight. So that leads to very cold temperatures. So it really makes it perfect for this methane hydrate, this methane gas molecules surrounded by water molecules. It's perfect for that to form.
What I was thinking first of hydrate is like a molecule containing hydrogen.
Yeah, that's not a bad guess at all. But really, hydrate is kind of a goofy term because hydrate isn't just limited to hydrogen, right? It's any gas you want. But water, H2O, water has hydrogen in it. So that's part of where the name comes from. So guys, if you have all this methane, it's down here, it's trapped, it's like stuck in these little like chambers, it wants to escape. Gas loves to escape. Gas loves to expand. So if this methane hydrate is poked in any way, I have a little toothpick. If we start poking that methane hydrate, guess what's going to happen? A lot of gas will get released. Gas will break from that hydrate. And once it reaches the surface, it's going to make the water look like it's boiling. So here you see the methane coming up, and the methane gas actually, expands. It comes to the surface, and it looks like bubbling water.
And hold on.
Yes.
Another thing is that methane is a flammable gas. So that's probably why they saw the fires.
Very smart. We're going to talk about that a little bit more about methane being flammable. I'm glad you cue me in on that because that's important too. So guys, methane gas, it comes up, it starts making the water bubble. And many of the myths have said, oh, we saw a brewing ocean and the ocean was brewing and bubbling and something fishy was going on. But if you look at the science behind it, there's a very high chance that it was just methane bubbles coming up to the surface. Now, what would happen to a ship if it were in those bubbles? Okay. Oh, sorry. If a ship were part of those bubbles, what's going to happen to the ship? Well, when you have bubbly water, the water is less dense. And if water is less dense, it means that it's easier to sink. So with that bubbly water, if a ship is caught in the bubbly water, it'll have a higher chance of sinking, okay? For planes, now let's talk about planes. I talked about ships disappearing. Now let's talk about planes disappearing because I know what you're thinking. Well, planes aren't in the water, so how would planes just disappear? But whoever said that about methane being very flammable, you're onto something. When methane comes to the surface of the ocean, it also moves past that. It starts moving into the atmosphere. And once it gets to the atmosphere, guys, in planes with a lot of heat, when they reach that, they can combust. So planes can set on fire because they have the heat, right? They're going so fast, their engines are so hot. And when they get in contact with a lot of methane, if you have enough methane, it'll cause the engine to set on fire. Another thing, and just one more thing, right? The methane, engines need oxygen. Have you ever seen maybe like a warning sign on, if you've seen like a plane show or anything like that? The engine will shut down if it doesn't have enough oxygen. So if you have too much methane in the air and not enough oxygen, the plane can crash. Okay, so that explains a lot of why ships and planes have kind of disappeared. It more has to do with this methane, at least with this theory. And then one more thing. I said I had one, that was the last thing. I have one more thing, right? You also have this idea of, okay, when the ocean is bubbling a lot, it actually will end up changing the magnetic field. And it has to do with a lot of electrons being produced. We talked about electrons a couple of weeks back. Electrons being produced, when you have a lot of electrons with that bubbling water, it will end up changing the magnetic field. So when a explorer said, when I went to the Bermuda Triangle, my compass was all wonky. It didn't know which way was east and west. Part of it could be these bubbles changing the magnetic field. Okay. Yes. Is there a question? Someone had a question?
I did.
Yes. Go
my
ahead.
question was, is there still anything like any monsters down there, or does methane reshape the
Yeah, so for monsters, there's been no proven monsters in the Bermuda Triangle. There's really been no proven mythological creatures or Atlantis or anything like that, kind of scary things that have happened. There's no supernatural things that they've proven. There's some science behind it, right? And that's what we're kind of talking about with these methane bubbles. But no, there is no verified monsters or anything like that. Okay. Is there another question?
I have a question.
I have a question.
Actually, mine's not a question.
Why don't we go Owen first? Owen, why don't you go first?
Just wanted to say that fuel actually refers to something burnt by an oxidizer.
Burnt by an oxidizer, right? So we get some oxygen in there. So you see what I'm saying? When you're burning fuel, and that produces a lot of heat too. So part of that heat, when it reacts with the methane, you have problems. Pandya, do you want to go next?
If there's gas in the Bermuda Triangle, why does everything mostly die off in the Bermuda Triangle? Doesn't this happen all over the world, but why is it mostly in the Bermuda Triangle?
Pandya, I am so glad that you brought that up, because that is a huge point that people are making. So this scientist that came up with this idea, it's a cool idea and it makes sense, but it doesn't explain the Bermuda Triangle. And really, what it shows is that there's nothing that fishy going on in the Bermuda Triangle in the first place, right? You might think, well, there's 924 deaths. If you look at the whole ocean in general, it's not, disproportionate in the Bermuda Triangle. It's not like there's more deaths, more disappearances just in that area. In terms of the whole ocean, the Bermuda Triangle fits right in. So that's exactly the point. That's exactly why the Bermuda Triangle myth is kind of busted, if we think about it, because there is no real evidence that says the Bermuda Triangle has blank more disappearances or blank more deaths than anywhere else. Okay, this is happening everywhere. This causes problems everywhere in the ocean. So it's not just responsible for the Bermuda Triangle. And the Bermuda Triangle is really something that's just a story. It's been passed on. But if you look at the science behind it, like that, what you're realizing, it doesn't make sense. There's nothing fishy going on in the Bermuda Triangle. Elias, did you have a question too?
Yeah. What pokes the water bubble around the atoms again?
Great question. We're going to actually talk about that right here. What is poking the methane bubbles? You have a really valid point, right? If no one is going down there with a toothpick and tapping these, what is actually breaking them? So I'm not sure how much you guys know about, maybe you have a telephone, your parents have cell phones or anything like that. But telephone companies have started to use underwater fiber optic cables. So what does that mean, guys? Fiber optic cables are going to be used that you can make a call to your relatives in India or in England or in, I don't know, Spain, wherever, right? So to make those calls and to have cell service pretty much everywhere on the planet, cell service, Wi-Fi, internet service, we end up with these things called fiber optic cables. And what telephone companies have decided is that, if we put these underneath the ocean, on the ocean floor, there are these running through the ocean floor. If you look at this map over here, oops, sorry, this map over here has tons, it's showing all the cables that are running around. You'll see that those can potentially rupture the methane bubbles, okay? If the cable breaks, if the cable shakes, if it snaps, if it moves, that's going to start to rupture some of those methane hydrates and release methane. And what's interesting, guys, if you look over here, right here where my cursor is, this is where the Bermuda Triangle is. Do you see how many cables are running through the Bermuda Triangle? Quite a lot, right? That is explaining, it's at least one possible explanation for why that methane would get released. Now, are there other things? Of course, right? But this is a big one, and it's kind of a new thing. But they've been wiring these cables, and they're seeing a lot of methane hydrate bursts. Okay. But I want to tell you something, guys. I told you about this, and this was an idea that was proposed by a guy, a geochemist. His name is Richard McIver. But his theory does have some problems, right? Just like Pandya was pointing out, it doesn't explain the spookiness of the Bermuda Triangle. It doesn't explain why the Bermuda Triangle, like it doesn't say, oh, wow, the Bermuda Triangle is special. It has these methane hydrate releases. Not so much. If anything, it tells us the Bermuda Triangle isn't special at all. There's really nothing fishy going on because those methane hydrate bubbles can happen anywhere in the ocean, right? If you have just the right conditions, if you have something to poke it, you're going to get methane hydrate bubbles in a lot of places. So it really doesn't explain the Bermuda Triangle, and it's just an idea. There's lots of problems with this, right? So there's a lot of different theories, but this is the one I think that has the most scientific evidence. I wanted to present you with something and say, look, this can explain some of the disappearances in the Bermuda Triangle, but it definitely it almost kind of disproves the Bermuda Triangle. People think it's this place where people just disappear and vanish as soon as they get there. Not the case, because what you're learning, guys, is that overall, the Bermuda Triangle doesn't have so many more deaths and vanishes than other places in the ocean. And all places in the ocean have these methane hydrates. So it can really happen anywhere. Okay. So I know that you maybe were hoping I'd have some kind of creature to tell you about that lives underneath the Bermuda Triangle. Unfortunately, I don't. But I do have some science, and I hope it made sense to you a little bit what is going on. Okay? And then, last thing, guys. I always like leaving you with something to discuss. So I presented you science, but you are your own scientist, and you can make your own conclusions. Do you really think something abnormal is going on in the Bermuda Triangle? Why or why not? Okay, and you can kind of think about this, chew on it a little bit, and let me know what you think. Okay? So now to our experiment. This one's a fun one. Any questions before we move on? Elias, you have a question? Or is your hand just up from last time?
It was up from last time.
Oh, okay, perfect. So I'm going to switch you guys over a little bit, and we are going to do our little experimento here. So this was fun. It's going to be looking a little bit at gases, okay? My computer, I'm going to show you the setup for this one. So first thing is this experiment, we start with a couple of materials we have. So first thing is this big tub right here. Okay? Perhaps you've seen this at Walmart or your parents have some of these. This is really just going to be called our gas chamber kind of thing, our little experiment chamber. This is where we're going to be releasing some of the gases we're going to be using today. So it'll just be important for looking at
we just don't want it to, the gases to release and the vinegar to release, and then things kind of go crazy. So I like keeping it in this nice little chamber. Everything's contained. It's a good place to start. Okay, so that's all. This is no like tricks or anything. This is just so I don't have vinegar and things all over my room. Okay, to keep things clean. Next, I have a quart size Ziploc bag. Okay, this is quart size. It's a little bit sturdier than your regular sandwich bag. It's a little bit thicker. And I also have a plastic Ziploc sandwich bag. Okay, this is one you probably use for snacks. I also have here some vinegar. This is just plain old vinegar. Nothing too special with this vinegar. I have baking soda. Oh, what bags? These are just Ziploc bags, like little plastic bags you use for like goldfish or something. This one's a little bit different. This one's a little bit bigger, and you'll see why I have two different sizes. I have a tablespoon measure and a little measuring cup here. It's a quarter cup. So first thing I'm going to do is I'm going to go ahead and in my little sandwich bag right here, I'm going to put 4 scoops of vinegar. Okay, so let's go ahead. I'm going to pour these in. 4 scoops of vinegar into that little plastic bag. Okay, and guys, if you're doing this at home, make sure you do it. If you're going to do it outside is probably best, because you'll see why. It'll show you in a second. It's best to do this outside, or if you can make a little chamber like I did, where you have space to release what's, I guess I don't want to spoil anything, but if you have that space, it's nice to have a little chamber for it. So 1, 2, 3. Okay. Let's build a little bit. That's okay. One more scoop here. Okay. So got lots of good vinegar here. Okay. And what I'm going to do is I'm going to seal up my bag. There's nothing really too exciting here. See, we're just going to seal it, kind of get a little bit of the air out of there. And we have our bag of vinegar. Okay. Pretty simple. Now in this bag, in my little bit larger bag, I'm going to go ahead and put 2 tablespoons of baking soda. Okay. And this can be rough, guys. It doesn't need to be perfect. So this is a little bit over, but that's okay. I'll go ahead and put 1 spoon and 2nd spoon. Two bags. Now I'm going to go ahead and move over a little bit, and I'm going to now get my little chamber here. And you'll see why we need a chamber. It's very important that you do this outside or you have a chamber. Things can kind of get a little wild. I have a lid for my chamber. Now what I'm going to do is I'm going to go ahead and put the bag with the vinegar inside of the bag with the baking soda. Okay, so you'll see what I'm doing here. I'm going to put it in with the green tab down. Okay, so green tab down. Just to let you know, guys, both bags at this point are sealed. Nothing is coming out. It's just in there. So I'm going to go ahead and flip that. Sorry, let me X this out. Okay, so I'm going to go ahead and put this in here. That, drop it in, seal up my bag, push out any air bubbles we might have. And now what I'm going to do, get this ready here. You guys can see it going in, maybe not so clear, but now what I'm going to do is I'm going to actually go through my bag right here. You can see my fingers are kind of going around here, and I'm going to try to open up this green bag that's inside of it. So I'm going to open it, and we're trying to let the vinegar out at this point. So remember, vinegar's in my little green sandwich bag. I'm going to try to open this up. So give me 1 second here. Very careful. You guys are careful, don't rip anything. So let me see. Okay. I'm going to open this and then we'll see what happens. All right, the bag has been opened. I'm going to flip it and put it in the chamber. Listen closely. You're going to hear something. It's bubbling. Put it in here. Listen closely. So you guys can see this. The bag has blown up. It's expanding. Yeah. And let's see what happens. It's rolling. What we should see, and it should in a second, this should happen. You should see it pop. I'll check it really quickly. I just don't want any vinegar to explode on me. I just moved it around so we get a little bit more vinegar. You hear that? Our bag popped. Pop. Yeah, thank you for the sound effects. Okay. So let me explain why I did this experiment for today. So what happens is baking sodium, right, as you close the chamber. Yeah, good thing I closed the chamber, right? Wouldn't that have been bad? I would have got baking soda and vinegar and all that stuff in my face. So here's what's going on, guys. Baking soda is sodium bicarbonate. Vinegar is acetic acid. When the two mix, you end up producing CO2. So we end up with this like vinegary baking soda solution. That's not so important for this. What we do end up producing though is carbon dioxide, CO2. Now, when I had it trapped in that bag, the carbon dioxide, we kept getting more and more and more and more carbon dioxide, and gas likes to expand. It likes to take up as much space as possible. And that's why I kept pushing on the bag, pushing until the bag popped. Okay. Now, why am I telling you about this with the Bermuda Triangle? Well, in the Bermuda Triangle and also just in general, when you see bubbles in the ocean, that is methane gas that's been trapped and it's released. It kind of explodes a little bit and comes up to the surface. So you can understand when the carbon dioxide kind of wants to get out, you understand the methane too. Methane gas wants to get out. It wants to come to the surface and come up. Okay. So any questions before we sign off? Anyone have anything that they want to ask? You do? Go ahead. Go for it. Yeah, Owen, what's your question? Oh, your mic is not working. Okay. Type it out for me. Let's see. We'll wait for his question here. Do you guys like that experiment? You like the bag when it popped? That was, yeah, it's pretty cool.
I didn't even see anything go out of it.
Yeah, if really, you don't see it's kind of like the liquid, like is able to stay in. Oh, Mrs. Ryder said hi. Oh, I had Mrs. Ryder oh my gosh, 5th grade. Well, tell Mrs. Ryder I said hi back. But that's awesome. So yeah, so really it's a cool experiment. If you actually do it outside, you'd really get to see it. You don't have to put it in like a chamber where, the problem with indoors and why you have to put it in a chamber is because it'll explode everywhere. And you don't want to get vinegar in your eyes. That'll hurt. So it's best off you do this outside. But unless you have a chamber like this and you close the lid. Okay. So look, guys, thank you all for signing on. Any last questions before we sign off? No? All right. Well, I hope you all learned something today about the Bermuda Triangle and what might be going on there and what goes on in the rest of the ocean too. Okay. And I'll see you next week. Bye.
Bye.